Imagine, just for a second, looking at a balance sheet and seeing a number so exceptionally massive, it almost defies the laws of business physics.
Right. It's hard to even wrap your head around.
Exactly. I mean, Nvidia just generated over $81 billion in a single 3-month period. Just think about the sheer scale of that demand.
It's staggering.
And here is the paradox we are tearing apart today. Meta actually helped create that exact demand.
Yeah, they did.
They are sitting there as one of Nvidia's absolute largest customers, just feeding billions into their coffers. Yet, simultaneously, Meta is pouring more than $125 billion this year into building their own vast infrastructure.
Right. Heavily focused on creating direct alternatives to Nvidia.
Yes, you really have to ask yourself why a company would actively feed a monopoly while spending, a small country's GDP to build a cage for it.
It's a massive contradiction.
It really is. And that is the mission of today's analysis. We are charting how Meta is attempting to claw back control over its AI expansion. We are looking closely at how artificial intelligence is fundamentally transforming software giants into, heavy industrial operators.
That's the key right there.
And we're looking at what this structural earthquake means for you. Because if you hold an S&P 500 index fund or any standard retirement account,
Which most people do.
right, if you do, you are effectively a shareholder in both sides of this massive collision, whether you realize it or not.
What's fascinating here is that this isn't some petty corporate dispute over pricing.
Right. It's not just billionaires fighting.
Exactly. It certainly isn't a clash of tech billionaire egos. We are witnessing a highly rational, almost ruthless negotiation over what is rapidly becoming one of the largest technology cost structures in human history.
Yeah.
It's about systemic risk, controlling the levers of production, and really securing the fundamental economic foundation of the next decade.
So, to really grasp the gravity of this shift, we have to look at the business model that made these companies so rich in the first place.
The old model.
Yeah, the old model. For the last 20 years, software was essentially weightless.
Right.
The beauty of the Silicon Valley model was that you could write a piece of code once, maybe sitting in a small office in California somewhere, and distribute it globally to 1 billion smartphones in an instant.
It was pure scale.
Exactly. You never had to pour concrete, you didn't have to lay miles of pipeline, and you certainly didn't have to build physical factories. The marginal cost of adding a new user was practically zero.
Practically zero, yeah.
But artificial intelligence has taken that pristine, weightless model and completely destroyed it. I mean, AI is incredibly heavy.
It really has shattered the illusion of infinite digital scale. Because artificial intelligence requires massive physical production facilities.
Yeah.
We casually refer to them as data centers, but let's be accurate here. These are heavy industrial factories.
That's a good way to put it.
Inside these massive concrete shells, you aren't just spinning up a few virtual servers. You are installing incredibly expensive, incredibly dense machinery.
Yeah, we are talking about hundreds of thousands of processors.
Right. Massive banks of volatile memory, high-speed networking switches, vast storage arrays, and perhaps most critically, the immense industrial cooling and electrical equipment.
Just to stop the whole thing from melting.
Literally, you need all that just to stop the entire building from literally melting down under its own thermal load.
It's wild. And that physical reality is showing up directly on the balance sheet, which brings us back to that staggering capital expenditure target.
Right, the capex.
Meta's capex projection for 2026 is sitting between $125 billion and $145 billion.
That number is it's insane.
It is. You do not spend that kind of money hiring coders or renting cloud space. That is the budget of a nation-state building a continental railway system.
To put the sheer physics of this into perspective, you really just have to look at their energy demands.
Oh, the energy numbers are terrifying.
Yeah. Internal plans show Meta is projecting an increase in its total computing capacity from around 7 gigawatts in 2026 to approximately 14 gigawatts in 2027.
14 gigawatts.
They are doubling a completely unprecedented electrical footprint in a 12-month span.
Okay, let's unpack this. Because that word gigawatts it changes the entire conversation.
It really does.
We traditionally use gigawatts to measure the output of nuclear power stations or, the consumption of entire metropolitan cities.
Right, not software platforms.
Exactly, not software platforms.
Right.
When a company whose primary product is a social feed starts talking about procuring power in gigawatts, it forces a complete reevaluation of their identity. It feels like we need to start analyzing these tech giants the same way we analyze industrial-era utility monopolies or global steel manufacturers, rather than nimble app developers.
That industrial framework is exactly the right lens. They are operating heavy industry now. And when you are consuming power by the gigawatt, managing the unit cost of your external computing hardware becomes an existential priority.
You have to keep it in check.
You cannot allow the cost of the physical chips to grow faster than the actual economic value the artificial intelligence creates.
That makes sense.
Right. Because if the hardware costs continue to compound exponentially, but the AI only brings linear improvements to, say, your ad targeting, the entire financial model of the company eventually collapses.
Which introduces the massive trillion-dollar bottleneck in the market, Nvidia.
Yes, the bottleneck.
If your survival depends on managing costs at an industrial scale, Nvidia's pricing power is your absolute worst nightmare.
Oh, absolutely.
Earlier, we mentioned that $81.6 billion in total quarterly revenue. Well, a staggering $75.2 billion of that came directly from data centers.
That's almost all of it.
Almost all of it. But the metric that truly illustrates their dominance is their GAAP gross margin, which is sitting at an exceptional 74.9%.
75% gross margin. Let that sink in.
It's crazy. For anyone familiar with hardware economics, where companies constantly battle supply chains, defect rates, and logistics just to scrape by on, a 20% margin.
If they're lucky.
Right, if they're lucky. A 75% gross margin on physical metal is practically illegal. It's software-level profitability on heavy hardware.
The pricing power is unprecedented, but we really have to dissect why the market willingly pays that premium.
Right. Why do they pay it?
Well, Nvidia's moat is widely misunderstood. It isn't just that they design incredibly fast chips.
Right.
They sell a fully mature, deeply integrated platform. When Meta or anyone else buys from Nvidia, they aren't just getting raw silicon.
They're getting the whole ecosystem.
Exactly. They are getting the processors, the high-speed networking protocols specifically designed to make those processors talk to each other, highly optimized software libraries, and decades of debugging tools.
So it just works out of the box.
Basically, yes. Buying Nvidia drastically reduces technical uncertainty. Furthermore, their chips are highly flexible.
How so?
You can use an Nvidia processor to train a massive new frontier model one day, run basic inference the next day, and then adapt to a completely uninvented, unpredictable AI architecture next year.
But I mean, flexibility is expensive.
Very expensive.
And Meta is looking at their operations and realizing they don't necessarily want to pay a massive premium for flexibility they don't always need.
Right.
That is the driving force behind the MTIA program, the Meta Training and Inference Accelerator. Instead of buying everything off the rack, they are rolling their own hardware.
And they're moving fast.
They really are. The MTIA 300 generation is actually in production right now, specifically handling ranking and recommendation tasks. And the pipeline is aggressive. Generations 400, 400, and 500 are slated to roll out through 2027, expressly to handle the heavy lifting of generative AI inference.
The timeline is moving much faster than many anticipated, too. There is another upcoming processor in their lineup, reportedly known internally as Iris.
Oh, Iris.
Yeah. Current internal schedule suggests production for Iris is slated for September.
Wow, that's soon.
That's soon. And more importantly, this timeline follows the completion of a 6-week early testing process where no major problems were reported.
That's a big deal.
It's a massive deal. Moving a custom silicon design from testing to production that smoothly is a massive logistical victory.
So let's ground this in physical terms. Nvidia is effectively selling a fleet of highly specialized, high-performance, all-terrain vehicles.
I like this analogy.
Right. If you are exploring uncharted territory, say, training a brand new, multi-trillion parameter AI model where you have no idea what mathematical bottlenecks you'll hit, you absolutely want that all-terrain vehicle.
You need it. You need the massive memory bandwidth and the ability to handle literally anything.
Exactly. But Meta is not just exploring the unknown. A huge portion of their business consists of billions of highly predictable daily routes.
Very predictable.
They are ranking user posts, recommending short videos, translating text overlays, and delivering targeted ads. If you are running the exact same predictable route 3 billion times a day, deploying a high-end all-terrain vehicle is a massive waste of resources.
Because overkill.
Total overkill. A custom-built, stripped-down, hyper-efficient delivery van, which is exactly what the MTIA chip is, makes infinitely more economic sense.
Right. You pull out the expensive, power-hungry memory you don't need, and you just optimize for the exact algorithm you run every single day.
Exactly.
The physics of that analogy are spot on, and it zeroes in on the vital financial distinction in the AI industry.
Which is
The difference between training and inference.
right.
Training is the act of teaching the model. That is your uncharted territory requiring maximum flexibility and raw computational force.
Okay, and inference.
Inference, however, is the continuous everyday process of the AI actually doing its job.
Like answering a user request.
Right. Answering a request, ranking an ad, or generating an image based on a prompt. Meta's goal with these custom MTIA chips isn't to beat Nvidia on a generalized benchmark test of raw computing speed.
It's not about being the absolute fastest.
No. The objective is to drastically lower the cost per useful outcome, multiplied across trillions of mundane daily interactions.
Because saving a fraction of a cent on power and compute per interaction translates to billions in retained profit over a fiscal year.
Exactly.
But engineering this custom delivery van is incredibly complex. I mean, simply designing a cheaper chip doesn't magically translate into a cheaper overall operation.
It certainly does not. This is where the concept of total cost of ownership, or TCO, becomes the only metric that matters.
Right.
The purchase price of the silicon is just the entry fee. You have to calculate the upfront design costs, the outsourced manufacturing, the memory modules you pair it with.
The industrial cooling systems required?
Yes, the immense electricity bills, the ongoing software support, and critically, the actual utilization rate of the hardware.
Utilization is the silent killer here.
Absolutely.
If Meta spends billions developing a custom chip, and it ends up sitting in a half-finished server rack for 6 months because the developers haven't figured out how to optimize their code for it, that chip is effectively a depreciating liability.
It generates zero return while its useful technological lifespan is just ticking away.
Right. You face a severe timing risk where the hardware loses its strategic value before it ever yields a financial result.
Exactly. Furthermore, as these mega data centers push right up against the absolute maximum electrical limits of the local power grids, raw speed ceases to be the primary goal.
So what takes its place?
Performance per watt becomes the ultimate financial metric.
Performance per watt.
Yeah. If a custom chip allows you to execute 20% more calculations using the exact same electrical draw, you don't just save on your utility bill.
You potentially save billions by not having to permit and construct entirely new electrical substations and cooling towers.
Precisely. But unlocking that performance per watt relies entirely on the software layer playing perfectly with the new hardware.
And historically, software is the hardest part of the ecosystem to reproduce.
Oh, without a doubt.
Hardware is math and physics, but software is a massive ecosystem of human habits. You can build the most efficient chip in the world, but if software engineers refuse to learn the bespoke coding language required to use it, the chip is useless.
It's a paperweight.
Right. But this is where Meta has a structural advantage that almost no one else has. They don't just control the consumer applications and, Facebook, Instagram, WhatsApp. They actually created PyTorch.
This is crucial.
For anyone unfamiliar, PyTorch is one of the foundational software frameworks that the entire AI industry uses to build models.
Right.
Because Meta owns this foundational layer, they can build the compiler that automatically translates standard PyTorch code into the specific machine language of their custom MTIA chips.
They don't have to convince outside developers to adopt a new system.
Exactly. They handle the translation under the hood, vastly reducing the friction of adoption.
That vertical integration is a massive tactical advantage. Even with that advantage, however, Meta is not treating custom silicon as a silver bullet.
No, they're not putting all their eggs in one basket.
Right. They are deploying a comprehensive portfolio strategy. They are absolutely not abandoning Nvidia. They are simply diversifying their dependencies.
Which makes sense.
We see this clearly in their expansion of a multi-year agreement with AMD, which covers up to 6 gigawatts of accelerator capacity, with shipments scheduled to begin in the second half of 2026.
Here's where it gets really interesting, though. Meta controls PyTorch, which is great.
Yeah.
But now they are committing to maintaining an entirely new internal hardware architecture while simultaneously integrating vast amounts of AMD systems while still relying heavily on Nvidia for frontier training.
It's a lot to juggle.
It is. From an operational standpoint, aren't they just trading a massive hardware invoice to Nvidia for an equally massive payroll invoice?
That's a fair question.
They are going to have to employ an army of elite internal software engineers to debug, optimize, and harmonize this incredibly fragmented hardware environment.
If we connect this to the bigger picture, Meta has clearly run the math on that exact trade-off and concluded the payroll burden is entirely justified.
You think so?
Absolutely. They are willingly absorbing the immense cost of thousands of specialized engineers as the price of admission for long-term strategic sovereignty.
Okay, sovereignty.
You have to remember how rapidly AI architectures are mutating. A specialized hardware accelerator designed perfectly for today's models could become horribly inefficient if the underlying mathematical approaches change next year.
Right, could be obsolete fast.
Exactly.
Yeah.
By internalizing that heavy engineering capability, Meta is buying agility. They are securing the ability to instantly pivot their hardware and software in tandem rather than waiting 18 months for an external supplier to adjust a roadmap.
But this desperate push for independence exposes a fascinating paradox in the global tech ecosystem. Escaping one monopoly simply funnels these companies into an entirely different set of bottlenecks.
It really does.
Like Meta is partnering with Broadcom, and they are blowing past a 1 gigawatt initial commitment for these MTIA generations to help adapt their internal workloads into specialized physical hardware. But Broadcom and Meta don't own the factories that actually print the chips.
No, they do not. And this exposes what we can call the TSMC paradox.
The TSMC paradox.
Right. You have a wave of massive tech companies, Meta, Google, Amazon, all designing their own brilliant custom silicon.
Yeah.
This effectively democratizes competition at the processor design layer. But physical reality intervenes.
Always does.
Every single one of those unique, independent designs ultimately bottlenecks at the exact same advanced manufacturing facilities, primarily TSMC, Taiwan Semiconductor Manufacturing Company.
So the intellectual property is diversified, but the physical printing press remains a terrifying single point of failure. And the complexity doesn't stop at the processor. According to Reuters, Meta's internal supply chain plans involve massive multi-year arrangements just to secure the peripheral components.
Everything else that goes in the box.
Right. Memory modules, flash storage, and a staggering amount of fiber optic equipment. Because these AI chips don't work in isolation.
No, they have to constantly share data back and forth during training.
Exactly, requiring an immense web of fiber optics just to allow the chips to communicate at the speed of light. Meta is no longer just writing software. They are acting as the general contractor for a sprawling global industrial supply network.
And coordinating that physical network forces these digital companies to collide with the physical world in ways they historically avoided.
Yeah, you can't just ignore the real world anymore.
You really can't.
Yeah.
An AI data center doesn't just sit quietly in the cloud. It strains local municipal power grids.
Which immediately sparks public resistance.
Right. And forces intense negotiations over who absorbs the capital cost of upgrading transformers and transmission lines just to keep the lights on for the surrounding community.
The secondary ripples are massive. It radically alters local labor markets, too.
Oh, absolutely.
A new data center creates an intense, localized demand for heavy electrical contractors and industrial cooling specialists, while the AI running inside that very building might be systematically automating away white-collar customer support jobs in the same time zone.
It's a bizarre dynamic.
It is. Then you introduce the geopolitical layer, where complex export controls dictate exactly which microscopic components can be shipped to which geographic facilities.
It gets so complicated so fast.
And add in the fact that this insatiable demand for high-bandwidth memory and advanced packaging squeezes the entire global electronics supply chain.
Which can indirectly drive up the manufacturing cost of consumer laptops and smartphones.
Right. So looking at all of this, relying entirely on TSMC for fabrication, competing for constrained memory supply, and begging local utilities for electricity, is this massive pivot actually independence, or just a vastly more complicated flavor of dependence?
It is definitively not full independence.
Okay.
Thinking of it as independence is a conceptual trap. What Meta and its peers are doing is executing a strategic exchange of risks.
Strategic exchange.
Yeah. They are deliberately trading a highly concentrated, incredibly expensive dependency on a single dominant supplier, Nvidia, for a much broader, decentralized, and complex web of global dependencies.
So the risk isn't eliminated.
Not at all. It is just reallocated across different failure points.
And Meta is far from alone in making this exchange. This is the new baseline for survival.
It really is.
Google has been iterating on their custom tensor processing units, or TPUs, for years. Microsoft is aggressively developing their Maya processors to run Azure. Amazon has their Trainium chips. And we are seeing reports of Project Rainier utilizing nearly 500,000 Trainium 2 chips for massive workloads as we speak.
The competitive landscape has irrevocably changed. Developing custom silicon is no longer a niche experiment or a vanity project.
Right.
It is a mandatory industrial strategy. But it is a strategy strictly reserved for the absolute largest tech giants.
The ones with the deepest pocket.
Exactly. Consider the staggering upfront capital required. Smaller AI startups or even mid-sized tech firms simply cannot afford to fund multi-year chip design teams, contract advanced manufacturing, build dedicated data centers, and absorb the catastrophic financial hit if a hardware cycle fails.
It's just too much risk.
Way too much. This creates a permanent structural disadvantage, where the rest of the industry will be forced to pay premium market rates for rented cloud compute.
The market consequences of this are going to be wild to watch unfold. We are entering an era where we have an explosion of diversity in chip design, thanks to Meta, Google, and Amazon pushing the envelope. But simultaneously, we are going to see massive market concentration. The few megacorporations capable of deploying these chips at scale will drive their internal computing costs to the floor, while every new competitor pays a massive tax just to access the hardware.
We also have to scrutinize the systemic financing risk underwriting this entire infrastructure boom.
Yeah, how is this all getting paid for?
Well, Meta is in an incredibly privileged position. They fund this massive capex build-out largely through their relentless advertising cash flow.
Which just keeps coming in.
Exactly. They can essentially self-finance the future.
Yeah.
But the wider AI industry does not have that luxury.
They don't.
Much of this global data center expansion is being financed through complex corporate borrowing, private credit markets, and specialized infrastructure funds.
That sounds fragile.
It is, because if the commercial demand for AI software applications stalls, or if the revenue doesn't materialize on the same timeline as the debt obligations,
refinancing those multi-billion-dollar hardware bets becomes incredibly perilous. So what does this all mean? When you zoom out, the sheer scale of capital being aggressively poured into physical infrastructure makes this AI boom look remarkably similar to the railroad boom of the 19th century.
That's a really good comparison.
Right. The railroads fundamentally, permanently altered global commerce. That was an undeniable fact. But the success of the technology did not guarantee the success of the investors.
Far from it.
Massive amounts of capital were entirely vaporized because companies overbuilt, laid track in the wrong places, or just couldn't sustain their debt loads before the freight started flowing. We might be looking at a future where artificial intelligence becomes a globally indispensable utility, yet the specific massive infrastructure investments made by some of these tech companies still end in spectacular financial ruin.
This raises an important question, and it forces us to evaluate the actual paths forward for Meta's incredibly expensive bet.
Right. How does this actually play out for them?
When we look at their custom silicon strategy, there are two highly credible divergent scenarios: the positive case and the cautious case.
Well, the positive case seems to hinge on execution. In that scenario, Meta delivers the MTIA generations on schedule. The internal software compiler does its job perfectly, making the hardware transition invisible to their engineers.
That would be the dream.
Yeah, they achieve massive utilization rates, drastically improve their performance per watt, and structurally improve their profit margins for their massive, repetitive workloads. They continue to buy Nvidia chips to chart the unknown frontier models, but they secure a much lower, highly controlled cost structure for their core daily operations.
That is the bull case.
Right.
The cautious case, however, is a scenario where the underlying mathematics of AI outpace the rigidity of the hardware.
Meaning the math changes faster than the chips.
Exactly. The MTIA chips become obsolete before they even clear the loading dock. TSMC manufacturing yields disappoint, driving up the per-unit cost.
Oh, man.
And the software migration becomes a nightmare, draining elite engineering resources away from actual product development for years.
Just a disaster all around.
Right. Under this scenario, Meta still ends up having to purchase just as much Nvidia hardware to stay competitive, and the entire custom silicon program simply acts as an extraordinarily expensive redundant insurance policy.
Ouch.
The true measure of success here will not be benchmark tests presented on a conference stage.
Yep.
The real scoreboard is measuring how much external compute capacity is genuinely avoided and whether those billions of dollars in avoided costs actually flow to the bottom line.
Or simply evaporate into ever-expanding infrastructure budgets.
Exactly.
Bringing this all together, the central realization of our analysis today is profound. Meta's massive infrastructure pivot is not a strategy designed to destroy Nvidia.
No, it's really not.
The reality is that Nvidia's integrated platform will likely remain absolutely essential for pushing the boundaries of frontier AI training, and both of these massive entities can, and likely will, grow exponentially side by side.
They're going to coexist.
Yeah. What we are really witnessing is the evolution of the market. The first phase of the AI war was a frantic scramble just to secure compute power at any price.
Just get the chips, whatever it takes.
Exactly. The next phase, the one we are entering right now, is a brutal, calculated war over controlling the cost of that compute power at a global industrial scale. Subscribe to the Unlayered Global now, because this channel does not just explain the headline. It reveals the hidden system underneath it.
As you process the mechanics of that hidden system, I want to leave you with one final thought that extends beyond the balance sheets.
Okay.
If the ability to absorb the brutal, multi-billion-dollar economics of custom silicon and industrial energy procurement becomes the ultimate barrier to entry in this space, we have to look very closely at the landscape.
What are we looking for?
Are we truly watching the democratization of artificial intelligence? Or have we just witnessed the moment the economic drawbridge was permanently pulled up, ensuring that the future foundation of AI will be firmly dictated by 4 or 5 megacorporations?
A massive structural question to leave us on. Thank you so much for joining us for this analysis. We will catch you next time.